Is extra.
Polyatomic ions are what we would call group ions. So far, what we've been dealing with in our previous naming and ionic compounds, all of those ions are monatomic, meaning they only consist of one element, okay? One particular element. Here, in nature, some of these other elements, a lot of them are all nonmetals. They can come together as a group, and as a group, they end up picking up extra electrons. If you pick up extra electrons, you have more electrons than protons, you are now an ion. There's a couple that as a group they lose electrons and become cations. There's only a few polyatomic cations. The majority that you're going to be looking at in our particular scope of our course are going to be anion polyatomic ions. So basically here, showing, you can see on this particular graphic, these have all these ones that are bonded, okay? So like for example here, this nitrate looks like this right here. Nitrate is one of the ones you have to memorize too. So nitrate is NO3 with a -1 charge. Basically what's going on here is that there are 3 covalent bonds here between the N and the O's. And when I say covalent bonds, that means they're sharing electrons. But when they came together as a group and formed this group, they ended up picking up 1 extra electron, pulling that in, so they end up having a -1 charge. But they are a group effort for the ion. So this is going to have a -1 charge on it. The NO3 is acting exactly the same way as, say, like Cl- would. Cl- or chloride is monatomic because it's only of the one element. NO3 nitrate happens to be composed of 4 atoms, 2 different ones, nitrogen and oxygen, but they act the same way in the compound because it's always about adding up the charges to make them equal 0. That's how you get your ratio. So it doesn't matter if the ion is from a group or if it's from a single particular element, they act the same way when you're trying to write the formulas. And because polyatomic ions are groups, the only added little layer that you saw that we need to put in here is if it's more than one, we have to use parentheses, okay? So basically, we're going to get into just adding that one little piece. Now this list here is 8, and this is on your particular notes sheet as well. These are 8 that you have to memorize. You have to know off the top of your head. These are the most common, most frequently used ones. These are the ones that they also put on the SOL, not that the majority of you have to take the chemistry SOL this year. But the most frequently ones that we use in chemistry are on this list of 8. Now, the other sheet that I gave you that has the chart with the other ones on there, those ones you don't have to memorize. We used to make you memorize all 28 of them. But the ones on the other chart, we don't make you memorize those anymore. You will be provided that chart to use on tests and quizzes. You just have to be able to utilize them. But for acetate, hydroxide, nitrate, carbonate, sulfate, phosphate, ammonium, and chlorate, these ones up here, you do have to memorize the formula and charge here because you do need to be able to just use those on quizzes, okay, or tests, because they are the most frequent and ones that you need to know. Now, once again, in the chart here, you do not have to include the ones like for ammonium here, NH4. I always just write it as NH4 plus because the +1 is understood to be 1. You don't have to write the ones in there. They're up here, but you don't have to write them in. That's understood. Okay? Now, each polyatomic ion is 1 unit. They're always together. And that's why I said you have to use parentheses because this keeps them together as a group. So parentheses. So for example here, for hydroxide is OH minus. like there. If you write OH and then put the 2 on there, the 2 is only applying to the H. It's not applying to the O. But if you put the 2 outside parentheses like this, guess what? Now it distributes to both things inside the parentheses, just like in math. It's like distributing, okay? All right, so we're gonna do a couple of these and I'll let you do some practice. All right, so here potassium, symbol and charge, the cation, what's that going to be? K plus. We know potassium is K plus. Good. Now, we just, until we have them memorized, we go to our chart and we look it up. What is sulfate? SO4 2 minus. Good. Now, how many of each do we need to make the charges add up to 0? So we need 2 of the K plus and 1 of the sulfate. 2 of the K plus, 1 of the sulfate. So we write the formula. It's very easy. This is K2SO4. You don't need parentheses for this one because there's only one SO4.
Could you still put them?
No, you would not put them in there. That would be incorrect. Only use parentheses if there's more than one. Like, for example, in the next one. So we have zinc nitrate. What's zinc's charge? Plus 2. Okay, plus 2. Look on your chart. What's nitrate? NO3 minus. Good. Now, how many of each do we need? We need 1 zinc at 2 plus, and we need 2 nitrates at minus 1. Now, since the zinc is a plus 2 and the nitrates are minus 1, we're going to need 2 nitrates to balance this out. We need 2 negatives. So when you write the formula here, you write Zn, then you have to put the parentheses around the NO3, and then you put a 2 outside. So that means we have 2 nitrate groups attached to the zinc here. Now, one thing to note about nitrates, like I said, very common. They're found in fertilizers and lots of stuff. And I'm sure you've seen on your meat labels too, where it says like no nitrates or nitrites in there because they're involved in lots of agriculture. And like I said, these 8 on here are ones that you'll see more often on food labels and things like that. Okay? But parentheses for that one because we have 2 nitrate groups that have to balance out the zinc. All right. Copper to hydroxide. So what's the charge on the copper? Cu2 plus, because the Roman numeral tells us. We look on our list. What's hydroxide? OH minus. Good. Now, how many of each do we need to make it add up to 0? We need 1 of our copper, 2 plus, and we need 2 of our OH hydroxides. And what you'll notice too later on in the year is hydroxide is actually a component of bases. You remember like acids and bases. Hydroxide's basic. It's going to be part of bases. So here we would put Cu, then we need parentheses around our OH, and then we stick a 2 outside like so. Let's do one more together, and then I will let you do some practice. Ammonium chloride. So this is the rare case where we have a cation polyatomic. Ammonium we look up on our list here. What is ammonium? NH4 plus, good. And chloride, what would be the anion for chloride? Cl minus, good. So how many of each do we need?
1.
Yes, we need 1 of each, right? That's easy enough. So, do we need parentheses for our NH4 this time? No, because there's only 1 of them, so you would just write NH4 Cl. Cations are always written first, whether or not it's polyatomic or whether it's just a metal. Okay? So go ahead, try a few more, and then we will go into naming. Okay, looking at these 2 here, the manganese 2 hydroxide and the nickel 2 phosphate. Manganese 2, because it's a multiple oxidation metal, gets a Roman numeral 2, that means it's plus 2. Hydroxide's minus 1, OH minus 1. That means you need 2 hydroxides for every 1 manganese to make it add up to 0. So it should be Mn parentheses OH and then the 2 outside as shown up here. Nickel 2 phosphate. Nickel is also multiple oxidation metal, gets a Roman numeral, so it's +2. Phosphate is PO4 -3. And so that gives us 3 nickels to every 2 phosphates here. So it's Ni3, parentheses around the PO4, and then you put the 2 outside. Okay, so here, looking at these last 2. Ammonium carbonate. Ammonium's NH4+, carbonate is CO3 -2. Now, the ammonium needs 2 here because they're only +1. So you have to do parentheses around the NH4 first, put the 2 outside, and then you just write out CO3 because there's only 1 of the carbonates. So that's one that looks a little different than others. When you have the cation in front, that's polyatomic and it's more than 1. The last one here, zinc carbonate. Remember, zinc is an exception where it doesn't have the Roman numeral because it's not a multiple oxidation metal. Carbonate is still CO3 -2, so it's +2 -2, it's 1 to 1. So it would just be ZnCO3. Okay. All right, the last one here, sodium acetate. Sodium is +1, group 1. Acetate has C2H3O2, a lot in its group, but it's only a charge of -1. So +1 -1 gives you 1 to 1 here. Therefore, you don't need parentheses. It's just NaC2H3O2 as your formula for that one.